This tutorial is on finding average atomic mass. So remember, when you have an element, there are different isotopes of each element. That's because they have a varying amount of neutrons, so their mass number is different. So when we look at the periodic table, the atomic mass given on the periodic table is a decimal due to it is an average atomic mass. So we are going to do some math to find average atomic mass. First thing you need to do is take the relative atomic mass of each isotope, multiply it by its percent abundance. Then you add those up. So if you have 3 isotopes, you're going to take mass times percent of isotope 1 plus mass times percent of isotope 2 plus mass times percent of isotope 3. That's just an example with 3 isotopes of whatever atom we're talking about. The problem will specify how many isotopes there are. Once you get that large number, the second step is to take whatever you get from here and divide by 100. That will give you your average atomic mass. So let's do an example together. Zinc has 5 isotopes. That means we're going to be doing this 1, 2, 3, 4, 5 times. So for every isotope, we need to take its mass number and multiply it by its percent abundance. Mass number multiplied by its percent abundance. Mass number multiplied by its percent abundance. Mass times percent. And this one here gives us a mass, but we don't have a percent yet. So we'll come back to that. So I'm going to start by writing it out. So for my first isotope, I have 63.929 multiplied by 48.63 plus 27.90 multiplied by 65.926 plus 4.10 times 66.927 plus 18.75 times 67.925. So that's for isotope 1, 2, 3, 4. We need one more, plus 5. Well, we have a mass for the 5th isotope, 69.925, but we don't have a percent yet. Remember, percent, this is all the isotopes that we have for zinc. So if we have 100% of the isotopes, which we do, each of these percent abundances must add up to 100. Well, here's percent, 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 percent. We're going to take these 4 percentages and add them up. 48.63 plus 27.90 plus 4.10 plus 18.75. When you do that, you should get 99.38. That is the percent of the first 4 isotopes altogether. So the last 5th isotope, it is whatever is left remaining after those ones. So 100 minus 99.38, 0.62. So this is our percent here. Alright? So you must have a percent abundance and a mass for each isotope. You multiply those together for isotope 1, isotope 2, isotope 3, isotope 4, isotope 5, and add that all up to get a very large number. So my calculator says this. That's your first step. The second step was to divide by 100. So my final answer is 65.39550062 atomic mass unit. That is my average atomic mass, because I had 5 isotopes. I took the mass of each isotope, multiplied by the percent abundance of each isotope, added all those up, got my large number, and divided by 100. Now let's talk about the graph. In a graph, you can graph the different isotopes and their percent abundance. The percent abundance goes on the y-axis. The mass number goes on the x-axis. So let's say we're going to graph our 5 isotopes. And this 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Gorgeous graph. Okay, so what you do when you graph is you take the percent is going to be your y-axis, and the mass is going to be your x-axis. So my first isotope is 63.92, and the percent is 48.6. I am going to go to my graph, and let's take a look at the mass. 63.9 is close enough to 64, so I'm going to draw the peak at 64 on my x-axis. And I'm going to take it all the way up to about 49%. So from 64, I'm going to go up to almost 50, and there's my peak. So that's for my first isotope. My second isotope is isotope 65.9, so I'm going to draw the peak at 66. The percent is about 28. So I'll draw that here. Then for the next one, the isotope 3, it's only about 4% abundance, and the mass is about 67. So it's a very small peak. And then for my isotope 68, it's about 20%. I'm going to draw the peak up there. And then for my last isotope, which is actually at 70, it is so small, look at the percent. 0.62, so it's a very, very small peak. And that was not drawn well. So this should be smaller than that one. This here, this data point, tells you your mass and your percent abundant for each isotope. So each peak talks about each specific isotope. The x-axis is the mass, the y-axis is the percent abundance.